Hey everybody, this is Mr. Munson, and we are in chapter 4, congruent triangles, continuing with concept 4.6, which is proven triangles are congruent with shortcuts. So right now, today lesson, we're going to learn the shortcut of showing triangles are congruent using ASA and AAS, and they stand for angle side angle and angle angle side. Now below I have 4 triangles, and they're two pairs down there that are actually congruent to each other. And so what I want you to do is see if you can figure out, without even getting the lesson today, see if you can figure out which triangles match up to which, and by angle side angle, and which two match up to being congruent by angle angle side. Put me on pause, think that through. There's no answer. You're just going to see if you know it. Okay? Take care. Moving on. So in our vocabulary list, we had included side that we skipped last time, so today we're going to fill that in. Included side is basically a side that is between two angles. So we had included angle last time, which is the angle that's trapped between two sides. This time we have a side that's trapped between two angles. So take a look at my triangle ABC. You'll see that I have two angles marked. Angle A and angle C are marked, and the included side that goes with those two angles is the segment AC. So hopefully that's clear as I don't know any simpler way of putting that, but that is what it is. Let's move on. So we have 6 ways that we're going to learn in this chapter to prove triangles congruent. So far, we have 3 ways to prove it. One is called what I call brute force. You just show every single thing in one triangle matches every single thing in the other triangle. So 3 sides in one triangle are congruent to 3 sides in another, and you have to show that the 3 angles in that first triangle match 3 angles in the second triangle. Okay, so that's a lot of work. That's 6 pairs of things you have to show are congruent to show that the triangles are congruent. Well, last chapter or last video, we learned a shortcut. Matter of fact, we learned 2 shortcuts. It wasn't that we had to show everything was congruent. It was enough to show triangles are congruent by using side, 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 or side, angle, side. If you don't remember what those things are or need to review that, please go back to 4.6 part 1 video and review those. Okay, so today we're going to look at ASA, which is angle side angle, and AAS, which is angle angle side. Next class or next lesson is going to be HL, and I'll not tell you what kind of triangles it is, but I'll give you a hint. The H stands for hypotenuse. So I wonder what kind of triangles those are going to be. Let's move on. Okay, so we're looking at a postulate again, a new one. This is one of the shortcuts we're going to learn, angle, side, angle. So it basically says this: if 2 angles and the included side of one of the triangles are congruent to 2 angles and the included side in another triangle, then the 2 triangles are congruent. So take a look at my figures here. I have 2 triangles, and it basically says, the if part says, look, if I have 2 triangles where on the left side I have 2 angles that are matching 2 angles in the right triangle, and the included side, that's the side between the 2 angles, if those things are all matched up, then that's enough to conclude, you ready, that the triangles are congruent. Okay? But it also allows me now, after I know that the triangle is congruent, I have this other question for you. This also means that angle A is congruent to angle D. So the question I'm asking, though, is for you to put me on pause and then try to think through, why would angle A be congruent to angle D if all we know is the triangles are congruent? Put me on pause and think that through. Well, here's my reasoning. Since the triangles are congruent, then triangle ABC is congruent to triangle DEF. Okay, so fair enough. I matched it up. I made sure that the order of ABC was in alphabetical order, and then I just matched up the angles and everything at the DEF. Therefore, angle A is congruent to angle D by CPCTC. Now, we learned that in a previous lesson, what that meant. CPCTC stands for corresponding parts of congruent triangles are congruent. So to use CPCTC and all those other letters, I have to know triangles are congruent. Well, I just concluded that. Now that the triangles are congruent, I know that their corresponding parts are congruent. This is really important. So once I have once I have the triangles congruent, I can say that that angle is congruent to that angle by CPCTC. One last thing, write this in your notes. To prove triangles are congruent, you would use either side, side, side side, angle, side. Right now, we just learned angle, side, angle, and later we'll learn angle, angle, side, as well as HL. Those are ways that we're going to prove triangles are congruent. The way you prove their parts are congruent is using CPCTC. So when I ask you, hey, how come angle A is congruent to angle D? Don't give me side, side, side. That's all stuff about triangles being congruent, not parts. And so make sure you have those concepts down and you write yourself a note or whatever you need to do. Make sure you don't get those mixed up. All right, take a look at these three triangles. See if you can identify which triangle pair are congruent by angle, side, angle. Put me on pause, see if you can figure that out. I'll give you the answer in just a moment. Okay, that's the answer there. Those two triangles are congruent to each other, so that's these two right here. This triangle over here filled out. It might be the trickery, but if you take a look, the side that's congruent is not included. We needed to have that side there marked as being congruent. That's why that one failed. Let's look at another one. All right, try to see if you can figure out which one of these two triangles are congruent by angle, side, angle. Put me on pause, come back and check your answer. Okay, GHO is congruent to NIF. Once again, this one here failed because the side that was congruent wasn't included. It needed to be right there to be part of the pack. All right, let's do another one. Okay, given BA is congruent to AE, whoops, I gotta add something here. Okay, given BA is congruent to AE and angle B and angle E are right angles, is this enough information to conclude that the two triangles are congruent? If so, state your reason. Okay? Go ahead and put me on pause and see if you can think this through. The first step I would do is I'd take the given information and mark my drawing. Then I'd start looking for any information that might be a freebie and then see if that's enough. Okay? Put me on pause. Okay, so I marked it, so definitely that doesn't look like a right angle, but it is. I'm just a horrible drawer, right? The information tells me so. I'm going to mark these angles right here as being congruent. That's a freebie, vertical angles. And so now I can tell you that this looks like these triangles are congruent by angle, side, angle. Okay, because I have an included side between two pairs of angles that are congruent to each other. Okay, hopefully that made sense. Let's move on. Another shortcut to add to our thing, an angle side postulate. If two angles and a non-included side of one of the triangles, a non-included side, you can look down at the drawing if you need to understand what that means. Non-included side of a triangle are congruent to two angles and a corresponding non-included side of another triangle, then the angles of the triangles are congruent. The reason this says corresponding, this is really important. This is where you start making mistakes if you don't do this. If you take a look at the first triangle, across from the double struck is the non-included side. So in the second triangle, it has to be across from the same angle. Okay, so make sure that that's setting up correctly. So if you look at these drawings, if I have this scenario where the left-hand drawing has two pairs of angles and a non-included side that are congruent to two angles and a non-included side as it in the right, then I get to conclude then the triangles are congruent. Why then can I say that segment BC is congruent to FE? Now we just talked about this, so if you don't remember what I talked about, just rewind me and go back to the previous problem where I had you kind of state the reason why on a similar problem to this with the last shortcut. Okay, and put me on pause. See if you can think it through. If you're just writing what I'm writing, you won't remember it, and that's not a good way to learn. So let me encourage you to go back and look at it and think it through, and then you'll own it. Okay, since the triangles are congruent, their corresponding parts are congruent by CPCTC. So therefore, BC is congruent to FE. Now, for those more advanced students, I want to show you a really cool thing. When you stack three little balls like that, this is your conclusion. This means therefore in the world of math. Okay, so if you want to look to the next level of dignified in the math world, you stack those three little balls like that, and you can put it as your answer. Therefore, BC is congruent to FE. All right, very cool. Moving on. All right, let's take a look at this one. It says, given C is the midpoint of AE and the two marked angles are congruent. Are the triangles congruent? Reason why. Okay, so make sure that all the information that is in the example in the writing there is displayed in the drawing. Um, then see if you can come to a conclusion if the triangle is congruent and the reason why. Go ahead and put me on pause, see what you get. So this is what I have. First of all, C is the midpoint of AE is code for saying that those two segments AC and CE are congruent to each other. Also, I get for free the vertical angles are congruent, so I go ahead and mark those without them even having to tell me. And this looks like it looks like to me an angle side situation. Now let's just verify, make sure that we have it over here and the corresponding pieces over here. So angle side are two sets of angles that are congruent in the left-hand triangle that match the right-hand triangle. They do. There's two over there. And then the side that's not included is crossed from the same angle. That's really important. If that had been like this, then it would have been across from the wrong angle, and that wouldn't have worked. Okay, so be careful about that. All right, so great. We get to conclude that these triangles are congruent by angle side. Now I wanted to introduce you to a thing called a two-column proof. And so we're just going to kind of go through this at a very cursory level, very high level, not super detailed. Just follow along with me on this, okay? See if you can follow my reasoning. When we're writing our statements, we're going to start creating a path of reason to show that these triangles are congruent, okay? So right now, just follow along with me as I write up this two-column. Okay, so you're just kind of getting used to what this stuff means. I'm going to write that angle M and angle K are congruent. The reason I can say that that is a true statement is because they gave it to me. So I write the word given in here, and I'm going to go ahead and mark them up here. M and K are congruent. Okay? Okay, second line. All right, WM is parallel to RK. Why can I say that is a true statement? Because they gave it to me. So I'm going to go up here and I'm going to mark my drawing with that information. I do parallel lines by drawing like little arrows on the parallel lines, okay? So now this might take us back a little bit. Let me show you why I'm doing this. All right, so I just simplified my drawing. I took some of the part, I took WM and RK and I just drew it above it with that transversal, this one coming down, okay? So I just drew some of the drawing up there. Now I know that these two lines are parallel, and because they're parallel, I know that these two angles are going to be congruent to each other. The reason is because back when we did parallel lines, I recognized those to be alternate interior angles, right? So if they're alternate interior angles, then alternate interior angles are congruent when the lines are parallel. So I'm going to steal from that previous section that idea, and now I'm going to say these two angles are congruent to each other. And the reason why? Let's see, that would be the alternate interior angles theorem. Okay? That's why I'm allowed to say that those two angles are congruent. So I have a statement now that those two angles are congruent. Okay, great. Now you might not have any idea where I'm headed, but it's all going to come together at the end. All right, cool. So now let's see. I believe I can now say that WR, let me put that in red. WR is congruent to WR. Let me mark that. Okay, I'll go ahead and put a single strike in there. Just kind of match the standard that I do in class. All right, so that piece, WR in the top triangle is congruent to WR in the bottom triangle. We've talked about this in class. See if you can remember, what is the reason that I'm allowed to do that? Why am I allowed to mark those things congruent? All right, very cool. Hopefully you said the reflexive property. Okay, so now remember the whole idea is to prove that these two triangles are congruent. Hopefully you followed my reasoning for marking the drawing the way I did with the congruencies that I did. Now look at the drawing and ask yourself, is there enough information and can I use one of my shortcuts to show that those two triangles are congruent? All right. So I would conclude logically with the markings in that drawing that triangle WMR is congruent to RKW. And that's what they were asking me. When we're writing these two column proofs, what they're asking me to prove is always the last line. Once I can come to that conclusion, I have it. The reason why I can say that those triangles are congruent by angle side. I showed the first set of angles here are congruent. I showed the next set of angles here are congruent. I showed the set of non-included sides are congruent. And so I've logically drawn up a conclusion showing that the triangles are congruent by angle, angle, side. This is called a two-column proof, and I'd really like you to just take a few minutes and run through this section one more time and just see if you can follow along, maybe even anticipate what I'm going to do in this thing. And then let's go ahead and move on to our try it problem. All right, here's your try it problems. Basically, this should be pretty quick, okay? So what additional information would you need to show the two triangles are congruent? By one of the answers is looking at angle, side, angle. So I'm looking for what additional information you need to know. And the second one is for angle, angle, side. So the two triangles to the right have some information given. So you need to tell me what additional information would you need to figure out or know or have me give to you in order to accomplish using one of those shortcuts. The second one is this write a proof, okay? So I want you to start getting your hands dirty with writing these proofs. And so for those people who they'll give up right away. This might be a very give up right away kind of thing. That's no problem. You can just come in for help afterwards. You won't get credit for it, but you need to come in after school to get help on this, okay? This is a problem that we're on the left-hand side have given you all the statements. And on the down towards the bottom right, I have all the choices that I want you to use to place up here in whatever order. Okay, so just figure out where each statement goes, make sure it's right and makes sense, and you got yourself your very first proof. All right, guys, have a fantastic day. We'll talk to you in the next class.